Hello everyone. Let's see what is inverse of a function. So suppose we are having a function f from set a to b such that f of x is equals to twice x. Where set a is having element, let's say 1, 2, 3, and set b is having elements 2, 4, 6. Now we can represent it with the help of mapping diagram. Set A can be written like this, containing element 1, 2, 3, and set B can be written like this, having element 2, 4, 6. Now if you will take the input as a 1, our function f of x is equals to twice x. Here if you will take input as a 1 from the set A, okay, 1, your output will be 2 times 1, that is 2. Okay, that means image of 1 is 2 in the codomain set, that is B. Similarly, if you will take another element, that is 2, x as a 2, then y value will be 2 times 2, that is 4. Image of 2 is 4. If you will take x as a 3, your y value will be 2 times 3, that is 6. We can also represent the function f in the form of set, that is f is equals to set having all ordered pair where the input is 1 and the output is 2. We have taken input 2 and the output was 4. We have taken input 3 and the output was 6. If this way we are having a function, then inverse of a function means there exists another function. We can represent that function with f inverse, and that will be defined from just the reverse way, that means from set B to A. Okay, where we will take input from B and the output will come from A. Now this B is the same set B, the original set B, having element 2, 4, 6, and A is 1, 2, 3. Here f inverse, when you will take the input as a 2, your output will come out as a 1. Okay, and the function name is f inverse. When you will take the input as a 4, your output will come out as a 2 over here. When you will take input as a 6, your output will come out as a 3 over here. And your f inverse will look like this. It will contain all ordered pair, just the reverse way of f. That means here 2, 1 will be present, 4, 2 will be present, and 6, 3 will be present. So if ordered pair AB is present in F, then ordered pair B, A will be present in F inverse. Now there exists two most important conditions which needs to be fulfilled, then and only then inverse of any function will exist. So suppose we are having a function f of x is equals to x square, defined from set x to y. Let's say we are having set x as minus 1, 1, 2 and minus 2. This is set x, and set y has 1 and 4. Now let's take input from set x. So if you will take x as minus 1, you will do square of that and the output will be positive 1. Just like this. If you will take x as a just 1, your output will be 1 square, and again that is just 1. So same output we are getting. As you can see, this is many 1 function. If you will take input as a 2, your output will come out as a 2 square, that is 4. And if you will take input as a minus 2, still you will be getting the same output, that is 4. That means 2 and minus 2 both are giving output as a 4. Here if we will try defining f inverse, our f inverse will look like this. F inverse will be from set y to set x, where y is having element 1, 4 and x containing element minus 1, 1, 2 and minus 2. Okay, just reverse way, That means if we will take the input as a 1, our output will be minus 1, and same. If we will take the input as a 1, our output will be again 1. Now as you know, this is not allowed in function. One input cannot generate two different outputs. Okay, so this way this will not even become a function. That's why the first condition says that if we are having a function that needs to be 1 function, then and only then inverse of a function will exist. Since this is not 1, hence we are not able to create inverse of this function. Now let's see what is second condition which needs to be fulfilled. Then and only then inverse of function will exist. So suppose we are having a function f of x is equals to x plus 1 defined from set x to y. Let's say this time our set x is having elements 1, 2, 3 and set y has 1, 2, 3, 4, 5, 6. Okay, as you know, if we'll take input from the domain set, that is 1, our output will come out as a 1 plus 1, that is 2. Okay, the image of 1 is 2. Similarly, if we will take input 2, our output will come out as a 2 plus 1, that is 3. That means image of 2 is 3. If we will take input as a 3, our output will be 3 plus 1, that is 4. That means image of 3 is 4. Now here if we will try finding inverse of this function, that means f inverse defined from y to x, where set y is 1, 2, 3, 4, 5, 6. These are the elements of set y, and elements of set x are this. As you know, we just have to draw it reverse way. Okay, so previously whatever was the output, that will become input now. Okay, and we need to connect the same arrow just reverse way. So 2 we will connect with 1. As you can see, previously input was 1 and output was 2. Now the input will be 2, output will be 1. Previously input was 2, output was 3. We have to do it reverse. 3 will generate output as a 2. Okay, and 4 will generate output as a 3. Now here we can clearly see for f inverse, our domain set, each and every element of the domain set does not have its image in the codomain set. And again, this is not allowed in function. That means if we are having a function, it needs to be onto as well. That means codomain set must be equal to range. Then and only then you will be able to reverse that function and create f inverse of that. So again here, since this function is not onto, here codomain set is not equal to range. Hence it's not onto. And hence inverse doesn't exist over here. So our function needs to be 1, 1 as well as onto. That means bijective function, then and only then inverse of function will exist. I hope you understood the concept. Thank you.